Hello everyone, my name is Aaron Matos, a biomedical engineering student at the Polytechnic University of Puerto Rico. I am doing the research with my colleague Rafael Alvarez, an industrial engineering student. The research, the research is titled Development of Transradial Myoelectric Prosthesis Controlled by EMG Signals.
The goal of this investigation is to provide patients a higher quality of life by developing an affordable, functional, and adjustable prosthesis with a simple design and construction. Our content starts with what are prostheses, its origin, what is electromyography, myoelectrical prostheses, vacuum-assisted suspensions, prosthetic components according to the level of amputation for the upper limb, its methodology, the concept of operation, what is an Arduino, manufacturing process of these prostheses, factors in which they need to be taken in consideration when manufacturing these prostheses, and the materials and cost for myoelectrical prostheses.
Prosthesis. What is a prosthesis? It is a device designed to replace a missing part of the body or to make a part of the body work better. Missing or diseased eyes, arms, hands, legs, or joints are commonly replaced by prosthetic devices.
The origin of prostheses. The pioneers in the idea of prosthetics were the Egyptians. The first confirmed case use of a prosthetic device was confirmed in the year 2000, when research pathologists discovered an Egyptian mummy that had a prosthetic finger made of wood and leather. What is electromyography? Electromyography is a technique for recording the bioelectrical activity of skeletal muscles, the information of which, after its respective analysis, allows the diagnosis of neuromuscular diseases, rehabilitation, and the control of active devices and functional electrical stimulation schemes. Myoelectrical prostheses. In the development of these devices, they use electromyography controlled myoelectrical prostheses, EMG. This type of prosthesis works with signals produced by the contraction and relaxation of any muscle. These prostheses are called last generation due to the technology that is applied in their construction. They carry sensors called electrodes placed in the internal part of the socket that's positioned in a strategic place, and when the muscles contract, are activated and are capable of opening and closing movements of the hand, as well as prosupination and even palmar flexion movements. Myoelectrical prostheses are controlled and manipulated by an external means, which synthesizes the signals and sends them to the control card, and these work through servo motors, which can be worked intramuscularly, with sensors using needles or by means of electrodes, thus allowing them to capture the signal superficially. The prosthetic components, according to level of amputation for the upper limb, are composed of the suspension, the interface, the socket, and the terminal device.
Vacuum-assisted suspension. Vacuum-assisted suspension of prosthetic sockets uses electrical or mechanical pumps to create a negative pressure differential relative to atmospheric pressure between the interior of a prosthetic socket and the residual limb covered with a liner. The liner is a stocking-like stump sleeve that acts as a second skin between the movable, soft tissue of the stump and the hard surface of the socket. Armor liners provide user comfort and safety.
The methodology in the myoelectrical prostheses include its requirements, the CAD design, the myoelectrical systems analysis, the prototype printing, and the implementation of the prostheses along with the band and open loop control. These are called the verification portion of the methodology. Lastly, which is called the operation, is a discussion of the results and its conclusions.
This is the concept of operation of the myoelectric prosthesis. It has the brain and goes to superficial electrodes, and these surface electrodes detects the electrical impulse coming from the central nervous system. The amplification, its main purpose is to increase the level of the signal obtained with the electrodes and reject noise signals. The filters, analog filters, are built to obtain the best possible results. It allows to obtain the clean signal and discards an unwanted frequency. Sampling. At this stage, some frequencies are emitted so that the signal is not distorted. Data segmentation of data. This is composed of techniques and methods that are used to improve the condition of the data before extracting any characteristic from them. Characteristics extraction or extraction of features. In this model, pre-selected characteristics are calculated and presented for a later classification of them. In this way, in the classification stage, there will be an efficient process. The classification in this model, it recognizes patterns in the signals, which are classified by predefined categories. Arduino. Arduino is an easy-to-use free hardware and software-based electronics prototyping platform. We can build electronic circuits and program them with the board provided for use on the job. The hardware and its software is expandable and open source. It has great possibilities to create projects of all kinds. It has many applications and uses. It was decided to choose Arduino as a microprocessor since it has been of great use and ease for the programming of myoelectric prostheses in other investigations.
The manufacturing processes for the myoelectric prostheses includes the necessity of measurements from the patient. The prosthesis then takes a plaster and transforms it into a cast to use as a developmental guide. Then he uses that model. It's formed in using the patient's limb. A positive template is modified to create a suitable portable interface for the patient. A plastic replica is developed that is used to test the fit of the prosthesis. When the proper fit is achieved, the plastic socket is exchanged for a more durable material from the artificial limb. Now, factors to take into consideration when manufacturing a prosthesis for a patient. First would be comfort. The second would be the type of material, its weight, and its durability. The third would be the range of its complete motion and its handle or its manageability. The fourth and final would be the volume of the amputated limb so that it could have a good fit with the bonnet and the anchor. Materials and cost for myoelectrical prostheses. So our main materials that we selected were steel, aluminum, and titanium. Here you can see the cost per kilogram. The thermoplastic materials, though the cost for those materials per kilogram or pound, the covers, which would be neoprene, silicone, and nickel, and the electrodes with the most popular were the ECG needle electrode, the ECG surface electrode, and the disposable ECG electrode. In conclusion, myoelectrical prostheses are the most advanced prosthetic technology. They are functional and also include the aesthetic field. Also, they are essential to increase the self-esteem of the patient who suffers from an amputation. The benefit of them are innumerable for the people who use them. In short, developing a prototype of myoelectrical prosthesis is the goal in which it is intended to achieve a better quality of life for the patient.
We are very grateful for your attention.